So you're going to write, like yesterday we did greatest common factor, we did trinomials where A was not 1. Today we're going to do, where A was 1. Today we're going to do trinomials where A does not equal 1, which means that if you have ax squared plus bx plus c, we are for sure going to be doing example problems today where there is a number in front of the x squared, and we're going to see how that makes a difference for the problem. Now, Mr. Fulton, he taught this in a way where you guys did something called factor by grouping, and it's not my favorite way of doing the problem. When I watched you guys do the problem, it looked like it wasn't your favorite either. So I'm going to teach you guys a different method that I think that you will like. Okay, so we're going to throw away Mr. Fulton's method completely. We're going to do something new so that it feels related to what we did yesterday, and then so that we don't have anxious flashbacks from last week. Sound good? Okay. So here's the first example problem we're going to do. And this method I call slide, divide, bottoms up. Some people shorthand that to slide divide, but it works with trinomials specifically when there's a number in the front, and that number in the front is not a GCF. If it was a GCF, we would take the GCF out and we would do it like one of the more simple ones that we did in the warm-up today. This is specifically for the problems where there is not a GCF to take out. You look at the problem, there's still a number in the front. So we're going to do 3x squared plus 5x plus 2. So if you look at this problem, there's a 3 in the front. 3 is not a GCF. You can't divide 3 out of 5. You can't divide 3 out of 2. So the 3 in the front has to stay there. So we're still going to do the little x thing, but it's a little bit different. What you do is you take the 3 and you slide it over to the 2. So you're going to do 3 times 2. What is 3 times 2? 6. So we're going to look for numbers that multiply to 6 but add to 5. 2 numbers that multiply to 6 but add to 5. You could do positive 6 and negative 1, but that wouldn't multiply to the correct thing. It'd just be 2 and 3. Yeah, 2 and 3. Or 3 and 2. Whichever way you say it is fine. So in the parentheses, I'm going to put x plus 2 and x plus 3. Now, I know this is not the answer because x times x is x squared. It is not 3x squared. So what I have to do is I have to say, okay, I slid the 3 over to the 2. I did a slide. So now to undo that multiplication of 3 times 2, I have to divide something. So what I do is I go back and I divide by 3, divide by 3. So I did a slide. Now I do a divide. Now I look at these two fractions and I figure out if any of them can be simplified. Sometimes only one of them can be simplified, sometimes both of them can. So if I look at this, I can see 2 over 3 cannot be simplified, so I'm going to leave that one alone for a second. But this one can be simplified. What is 3 over 3? 1. It's 1. So for this one, I'm going to write x plus 1. Now, for any fraction that cannot be simplified, or for any fraction that is simplified and then stays a fraction, I bottoms up. And by that, I mean I take the bottom and I move it up in front of the x. So this other parenthesis is 3x plus 2. And that is my answer. So slide, divide, bottoms up. That's why we call it that, because it walks us through the steps. So what I remember is that if there's a number in front, it makes it a little bit more complicated, and slide, divide, bottoms up is a little bit more complicated. Okay, let's try another one. Let's do, this one is 7x squared minus 9x plus 2. So I look in the front, I can see that there's a 7. 7 is not a GCF. I can't divide it out from the other numbers. So the very first thing I do is I take the 7 and I slide it over to the 2. 7 times 2 is 14. So I'm looking for two numbers that multiply to 14 but add to negative 9. Multiply to 14 but add to negative 9. Negative 2 and negative 7. Okay, so in my parentheses, I'm going to write x minus 2, x minus 7. So I slid the 7 over and I multiplied it. So now I have to undo that. I'm going to undo the multiply by 7 by dividing by 7. And now I have to reduce each of my fractions if I can. 2 over 7 does not reduce. 7 over 7 is x minus 1. And this one we're going to bottoms up. And this one is 7x minus 2. Done. Okay, how do we feel? Good? Okay. Let's try another one. Okay, for this one, we're going to have 6x squared plus 11x plus 3. All right, so tell me what to do first. Slide. So 6 times 3 is 18. So we're looking for two numbers that multiply to 18 but add to 11. 2 and 9. Okay, so I'm going to say x plus 2, x plus 9. Okay. Now what do I do? Divide by 6. Okay. And this problem is kind of interesting because both of these fractions reduce and they stay fractions. So we need to reduce both of them, but we're going to keep them as fractions when we do it. So 2 over 6 is going to become what? 1 over 3. And 9 over 6 is going to become... We're going to do an improper fraction, so yeah, 3 over 2. Okay. And then if we reduce them and they stay fractions, what do? We bottoms up. Bottoms up. So 3x plus 1, 2x plus 3. Okay, 3k squared plus 2k minus 5. 3k squared plus 2k minus 5. What should I do first? Slide. Okay, so I'm looking for what multiplies to a negative 15 and adds to 2. 5 and negative 3. Okay, so k plus 5, k minus 3. And then what should I do? Divide by 3. Okay. So k minus 1. You're close. Plus 5. Okay. 3k plus 5. Okay, let's do 10k squared minus 3k minus 1. So what's our first step? Slide. Okay. So negative 10. So we're multiplying to negative 10. We're adding to negative 3. Negative 5 and 2. Okay. K minus 5, K plus 2. Okay. And then what do we do? Divide by 10. And then what do we do? We have to... Okay. So k minus 1 over 2. One over 5. Okay. Bottoms up. Okay. Well, these are kind of fun. Eh? Yeah. Yeah, factoring's not so bad. So I'll show you guys the way that he would have done this one. And his method isn't bad. I do show students his method. I just don't do it for these types of problems. I do it usually later on. Like I've taught his method, but in Math 4. So if he was doing this problem, he would keep the negative 5 and the 2. He would want you to do that. So the 10 times the negative 1, he would ask you to do that. He would ask you to find the negative 5 and the 2. And then he would have said 10k squared minus 5k plus 2k minus 1. He would have had you split it into 4 pieces. And then once you split it into 4 pieces, he would have you cut the problem in half like this. And between the first 2 pieces, he would ask you to find the GCF. What's the GCF of the first 2 pieces? 5. And what else? K. And then we would write the leftovers. What are the leftovers? 2k. 1. And it's a negative 1, right? Because there's a negative right here, so minus 1. Over here, there's nothing in common between these 2 pieces. So we would say, okay, the GCF would be 1. And then the whole thing would be left over. And when you guys were doing this, you would notice that your parentheses were always the same. Do you guys remember that, when you'd have your parentheses always be the same? So we would say, oh, if our parentheses are the same, it's kind of like this whole thing is the first term and this whole thing is the second term. And it's kind of like my parentheses are a GCF. The parentheses are a GCF of the first term and the second term. So you would take your parentheses out to the front, 2k minus 1, and then you would write your leftovers. Your leftovers are a 5k and a positive 1. Yeah, so that's how Mr. Fulton did it, which isn't a bad way of doing it, but it's not super student-friendly in the beginning. Yeah, the slide divide is students tend to like a lot more. Yeah, so, yeah. Yeah, so this isn't bad. You can certainly do it that way if you like. Actually, PhotoMath does it this way. So if you guys have ever used PhotoMath on anything, this is the way PhotoMath does it. But slide divide, because students cheat. So I've recognized it, yeah. That's how I used to catch students cheating at my old school. I'd be like, well, I taught you slide divide, and you're using grouping, and you don't even know what grouping is. Show me how you did that. And they'd be like, I don't know, I must have got it wrong. And I'm like, no, it's right. That's correct. How did you do it? I don't know. You don't know how you got that correct? You used PhotoMath. Oh, yes, you cheated. Cheater, cheater. All right. So let me give you a couple problems to try for the end of the period, and then I'll write down what your homework is. So let's try... These are part of your notes. Yeah, this isn't homework yet. So these are still going to be part of our notes. We're going to do 12b squared minus 13b plus 3 4v squared minus 15v plus 9 6v squared minus 7v minus 3 5x squared plus 18x minus 8. So these are just some to try in the next 15 minutes or so of class, and then I'll write down a homework assignment for you.